All right, so we're going to put this in perspective, a real-world problem here, guys. You're driving down the highway. Marley's in her green truck. And Rudolph appears out of nowhere on the road. Her foot is on the brake. Rudolph is 100 feet away. Is Christmas ruined? That is the problem. Let's put the context. All right. We're going to use the braking graph of a car given in problem 15 here from section 3.1 to answer this question. Because I will tell you guys right now, 60 miles an hour is about 88 feet per second. So maybe she's only going 50 on this graph. We better change it so it's right. She's going about 50 miles an hour. All right? So here's our problem. And this is what we're going to do. And the question is, her foot's on the brake, she slams on. Here's the graph of the time. Is Rudolph dead? All right? With that said, that's our problem. I'll group it. We'll save it. Our only way to handle this is to do a Riemann sum. And we have two options right now. We're going to have a third option later. But we have left endpoints or right endpoints. Now, how many intervals do you think you want to break 6 seconds into? Well, the more the better. 3, 2, 1. We don't want 1 because, guys, whoops. If you use a left endpoint, if you use a left endpoint with 1 interval, you would estimate the distance under that curve by the red distance under the rectangle. And we all agree 70 times 6 is 420 feet. That is a horrible estimate. All right? So then you might say, well, maybe we want 2 intervals. So do you guys agree each for an interval? 6 seconds split into 2 intervals would be 3 seconds each. And if you use the left endpoints, you'd have a rectangle this big and a rectangle that big. I don't know. That's pretty crappy. You guys agree? I don't even think that's worth figuring out. Well, I'm gonna go into seconds. How about we go 6? You guys, I'm gonna go 6 of them. All right, and we're gonna do Riemann sums with the left endpoint first. Left being, again, if you get confused, hold up your fingers. Left is the L, right? The left being this side. Okay, we're gonna do a Riemann sum from the left. And we're gonna give an estimate of how long is this car stopping. Whoops. Does Rudolph die? And should Marley be going slower? And I bet you the answer to that question is absolutely yes. All right, so we're going to do a left endpoint first. And I'm going to draw the rectangle so you really see them. So there's the left endpoint. And here's my first rectangle, guys. It is 1 second wide. And I'm going to call this point up here 70 feet per second. All right? So it's 70 feet per second by 1 second. You guys agree that area of that rectangle is 70 feet? All right. Well, so let's start writing this. So we're doing a Riemann sum to the left endpoint. Okay. Splitting it into 6 sections. So I have 1 second times 70 feet per second. The next rectangle, I don't know, what do you want to call it? 45? I'm going to call it 45 because I don't want to add those units. 45 seconds. There's our first 2. Okay, I'm going to do a plus sign. My next left endpoint is here. I'm going to call that 30. Okay, I'm easy. All right, 30 feet per second plus my next one. I'm going to call 25 because I like the math to be easy. Next one, 15. And the last one, I'm going to call 10. Now, my first question before I do the math, I'm going to do the math here in a second. Overestimate or underestimate? Over. Guys, look at the graph. Look at the graph. Look at all the extra. If I find this number is less than 100, Rudolph is for sure going to live. You guys agree? If this is 90 feet, boom, I feel no doubt that Rudolph is not going to die. All right. Since it's all times 1, I kept the math easy. 70 plus 45 is a 115. 145 150, 170. I get 195 feet. I'm not feeling too confident about Rudolph at the moment. Well, that's a left endpoint. Maybe I'm just way overestimating. I doubt it. Not that much. Maybe the question should be, should he get hit at 70 feet? But I can do a right endpoint. I'll do that in blue. A Riemann sum to the right endpoint. Now, everybody, since we have 6 intervals, what are we going to be times every time for the bottom of the rectangle? 1 second. Yeah, so listen, I'm going to tell you right away, it's going to look strangely familiar. Alright, whether it's a left or right. So that means you actually have to make your handwriting legible, and you have to keep track of stuff, which is, right? Alright, so we got this going on. Now, here's the other thing. If I use the right endpoint, there's the first blue rectangle, right? The right endpoint on the curve, and then the next one's here. Everybody, I want you to catch that right out of the gate. We are using the same point. We're just skipping the 70, and our first point in here is 45. The next one's going to be the 30. And this is coming from the previous problem, right? And then the next one's going to be over. It's going to be here, here, here. And we're using those points. So whatever points we used in the previous problem, we're going to have to use again. 25 feet per second, 15 feet per second, and 10 feet per second. And then I look at my last rectangle, and it's at a stop. Well, guess what? That rectangle is how high? 0. So it's the same answer as the last one, except take away the 70. Oh, poor Rudolph. Marley, you're going to have to apologize to millions of children all over the world, all right? Because I get a right endpoint here of 125 feet, right? Feet per second times feet is feet, which we know is a underestimate, right? Looking at the blue curve. I would say I for sure know Rudolph at 100 feet is in trouble. Now, this is not a great estimate either. The over is high. The over is very high. The under is very low. If you wanted a great guess, if you average them, 195 plus 125 divided by 2, it's 160 feet. So maybe my question should have been at 150. But don't worry, Marley. We know Rudolph. He would just disappear before you hit him. Go back and Santa. That's what the red nose is for. All right? Guys, this is a Riemann sum. Left endpoint, right endpoint. Where would this get annoying? If I asked for maybe 20 intervals, or 30, or 40. How about 10 per second? How about 60? At what point does this become too cumbersome? The good news for you guys, as I would argue, this borders on too cumbersome right now. 6 intervals is just borderline too much. All right? So, given any graph, we check our units, we know what we get. All right? We can always do the Riemann sums. And the last one we probably could try to do on this graph, and this we'll come to this later, but we'll talk about it now before we shut down the video, is maybe I don't want either of these. We know these are both kind of screwed. Couldn't we go back to the original graph and try to do, maybe on a 1 second interval, we do the midpoint, all right, of that interval. Yeah, well, the value at a half second, but at a 1 second interval. So then at 1.5, do you guys agree the function's about there? And a lot of times this midpoint of the interval, okay, is a lot better estimate. So I'm going to draw them out, then we'll talk and make sure we understand what I mean by midpoint of it. I like this. I would say this would be very close to 160. So for the first interval, it'd be a second wide, and you would take f of 0.5 seconds. Which in this case would be about what? 57, 55. All right? Keep going. All right. No, we got midpoints, guys. And the midpoint has to be in the center of your division. So if I had 1 second intervals, you're on half seconds. If I had half-second intervals, you'd be on quarter and three-quarter. All right, we'll get there. But again, these are Riemann sums, and they're a good approximation for graphs.